Okay, as a culminating activity or demonstration here, um, believe it or not, what you're looking at in a very basic way is how your house is wired. Um, so, in this unit on electricity, we have talked about two different types of circuits: series and parallel, and um, and I've done a demonstration of each of those that I've shown you. But to bring it all together, I want to talk to you about how your house is put together electrically speaking. So before I actually turn anything on, I'm going to point to certain things so you can kind of see how this is put together. And so if we come over to the left here, you'll see that this right here, that is our ultimate power supply, which for your house is where the electricity feeds in from the street. Now, if you happen to live in a neighborhood where you have utility poles and overhead wiring, you would notice the equivalent of this piece here coming in at a corner of your house. It'd be a nice thick wire that leads into, kind of connects in, goes down into your roof, and from there it goes to feed your whole house. If you are in a neighborhood where they have undergrounded the power lines, you would not see any of that. And in today's world, many people would say, God, you're lucky, because it's so much prettier when you don't see all the wires hanging along the street. Now, I have not plugged it in yet, but this is going to feed into this main block here. Now, you'll notice that I have taped off this center section and I have labeled it the breaker box. I don't know how many of you are familiar with your breaker box, and I think I might give you an assignment to send me a picture of where your breaker box is with the door open so you can see all the little circuit breakers inside of it. But when this feeds into the breaker box, you will notice here that we have one. I've put a switch wherever we would have a circuit breaker in there. We have one switch that leads out from the breaker box, and then it splits into these three pieces, and this piece leads over to this switch, which leads over to what I'm calling sub-circuit 1, which could be the living room or a bedroom or a couple bedrooms. This piece right here goes to this circuit breaker, which leads off to this sub-circuit 2, which would be another section of the house. And then this one here leads off to what we call sub-circuit 3, which would be another part of the house. And how many sub-circuits you have just depends on your house. Most houses will have a decent amount, at least a dozen or so. And then the red wiring all comes back to this terminal so that we can complete our overall circuit. So if you were to actually look at your wiring, you wouldn't have one that feeds in here and then another that comes back here. You would actually have two wires that would lead out here and then it would come back to here. But I didn't have that wiring available, so that's not what we're going to do here. Okay, so you'll notice that if we talk about connections, this is the only place that electricity can flow from this terminal out to the connecting point. So this guy right here is in series with this connection. And then feeding out from here, each of these switches, which represents this thing called a circuit breaker, is in series to go out to the light bulbs that are in each subcircuit. But once you get to the subcircuit, you will notice that from this connecting point where the electricity can feed in, it can either go through light bulb 1, or it can come over here to go through light bulb 2, or it can go through light bulb number 3. So these light bulbs, which represent either plugs or lights in the rooms of the various areas of the house that are part of each subcircuit, they are connected in parallel. So again, to quickly review that, everything here is connected in series, everything out here is connected in parallel. And the reason that we have these series connections here is because of safety issues. Because remember, with a series connection, that means there is only one pathway. So if it shuts down, everything after that spot will shut down as well. So if you've ever had the experience that one part of your house has shut down, that's because there's been too much electricity that's been demanded by a sub-circuit in the house, and that triggers a circuit breaker to click off because there is a safety hazard. Now, to try and show you this, I have the red guys here, remember, are set up as ammeters. So that will represent how much electricity is flowing through the circuit. This one right here that's by the breaker box, this shows you the total amount of current that is flowing into the house. And then each of these individual ammeters over here is how much current is just going through sub-circuit 1, how much is going through just sub-circuit number 2, and how much is just going through sub-circuit number 3. Now over here, I have also set up a voltmeter so you can see what the voltage is here at we'll call it the breaker box. And then I have set up another voltmeter back here, so if I want, I can show you what the voltage is at different spots in the circuit here. Okay, now at this moment, everything is turned off. So we're going to get started. So the first thing I'm going to do is plug in our power supply here, and you'll notice that our voltmeter now over here at the breaker box reads 14.28 volts. So now we are live, but we have no electricity flowing because nothing's turned on. Okay, so I am going to turn on this particular switch here, which is the one that leads out to the splitting point here. Now, I'm going to point out that my pointer is metallic, which means it might conduct electricity, so I will no longer use that as my pointer, and I'm just going to have to use my finger here. So I'm going to turn this on, and you'll notice that once I turn that on, nothing changed. But that now means that we have a closed circuit so that electricity can flow from here out to here. So if I go ahead and measure the voltage between this spot here, where it all comes back, and this spot here, you'll notice I get my 14.28. So now I have live voltage right here that can now go out into the different sub-circuits. Now, what I'm going to do is turn on each of these sub-circuits. Now those are on. And if you're going, wait a minute, there are no light bulbs going on. The reason I have done that is I have unscrewed each of these light bulbs because we are going to add them in one at a time so you can see what's happening. But if I come back to my voltmeter here and I come over to this particular circuit here and I touch on each side of this, you'll notice that I get the 14.28. So now I have voltage here. And if I do a similar thing, let's see, if I come over here and touch here, I get 14.28. Hey, that wasn't supposed to go on yet. So you can see it's live. And if I come here, I also get my 14.28. So now, no matter where I go, I have 14.28 volts. So when you think of buying electricity, one thing that I would want you to remember is you do not buy voltage. Once you have your voltage come into your house, all of your connecting pieces out in the house have voltage. What you pay for, and most people will say, I pay for electricity. Remember, actual electricity is actually current. And we have no current flowing through the system at this moment. So if someone asked, how much does this cost to run? The answer would be zero, because we are actually not running anything. Okay, so let's come to sub-circuit 1. All of our sub-circuits are live. So let's say I go into a room and I turn on a light bulb. That means I screw in One light bulb there. Now I got a light bulb going. You can see that I actually have current flowing through this sub-circuit, and it matches the current that is occurring overall. And that's because it's the only thing on there. Now let's say that we only turn on a light bulb there, and that's it. And then we don't turn off the light bulb, and we come to another room, sub-circuit 2, and let's say we turn on light bulb number 2. Now you'll notice that we have a current flowing through sub-circuit number 2. We still have the same current flowing through sub-circuit number 1, but if you come back to our master here, or our overall current, it is the sum of those two currents. So right now, this is more expensive than this because there is more current flowing through the system when we have two lights on. Now, let's say we go back to our first room and someone says, oh, I'm going to plug something in and turn it on. Like you plug in a floor fan because it's hot and you turn it on. That would be like screwing this light bulb in, and now the current going through sub-circuit number 1 has gone up, and the overall current has gone up as well. Now we are getting more expensive now. Now let's say somebody comes to the third room in the house and says, hey, I'm going to flip on the light switch here for this house or this room, and they turn that on. Now we have a current flowing through sub-circuit number 3. Sub-circuit 2 and 1 have stayed where they were, but our total has gone up. Okay? Now each time that we plug in another thing, it does not affect the voltage, because even if we come back here, now that this is on, if we were to measure what is our voltage here, we still get the same, we still get a voltage. It's not exactly the same, but it is commensurate, about the same as what our overall voltage is. Now remember, we have discussed this in a prior lecture. If someone ever says, well, why is there a little bit less voltage when you just measure here or here? Let's come over here to number 1 here. If we measure this, we get 12. The reason that we get a little bit less is because as all of this electricity is flowing through the system, a little bit of it does get used up between where it comes into the house and where it actually gets used by an electrical device or a resistor. Okay, so let's turn on something else. Okay, we turn on something else in sub-circuit number 3. The currents are just about the same for each of the sub-circuits now because we each have 2 lights on in each. But if you look at the overall current, this is the sum of those individual currents. And this is what is going to determine how much we pay. So when a parent comes in and says, you've got too many lights on, turn off a light, they do have a little bit of a point. If you could do your work properly with 2 lights, but you had 3 that were on, that costs you more. So maybe you could get rid of one of them and reduce the current, which means that would reduce the amount of electricity that's actually being used. So in the end, what we're going to do is, let's say we turn on all of these. And let's see what we get. Now, I'm not sure if you can tell that each time I bring more in, there's a little bit of a flicker, and then the lights actually dim a little bit. Some of that is because of our power supply, which is a little bit limited in terms of how much electricity it can supply. You can see right now our overall current is 1.58 amps. This adapter, our power supply, is really designed to only provide 1.5 amps. So we're actually maxing this thing out right now. And as a result of that, you can see that the light bulbs have dimmed just a little bit. If I had a power supply that was a little bit more robust and stronger than this, they might be shining just a little bit brighter, and you might not notice as much the flicker every time I bring in a light bulb or take one out. Okay, now let's go back to the safety area here in the breaker box. Let's say that you plugged way too much stuff in this sub-circuit 1 area, so that would cause the current just here to go way too high. Inside the breaker box, this little switch here, technically what we're looking at is a switch that I can control, but in a breaker box, these devices are like automatic. They're idiot proof. They are set so that if a certain number of amps are exceeded in that part of the house, they will automatically click off. So if for some reason we plugged in something that was going to demand way too much electricity here, and then we turned it on, what would happen is that this value would shoot up way too high, and this thing would flick off. And that would cut the electricity just to that part of the house. Now, if you've ever had this happen before, you know that circuit breakers are one of the nice things about them is that they're resettable, so that you could go out, if you know where the breaker box is, and you can play with the circuit breaker so you can turn it back on. Now, if we do that here, you'll notice again, these lights went a little bit dimmer because we're maxing out our power supply, but once we reset it, we can get electricity back to that part of the house. And that same thing can happen in each of these sub-circuits. If we plugged in way too much stuff in sub-circuit number 2, this circuit breaker would trip and it would cut the electrical flow, and you can see that it goes down to 0, and that means we got no electricity there. And we would have to come back to the breaker box, reset it, and then we could get the lights back on. Now, in very old houses, they are really not designed for a whole lot of current compared to today's more modern houses. And as a result of that, sometimes people have to learn, I can't turn these 3 appliances, especially in a place like a kitchen, at the same time. In my old house, it used to be that you couldn't run the microwave and the blender and the oven at the same time. And so you had to be careful if you knew you were going to run something to make sure that certain other things were turned off. And all that, even though it seems like a hassle, is designed for our safety. So that if you exceed too much current, because remember, if there's too much current, that means there'll be a lot of energy that gets deposited in that area of the house, and that could cause wires to heat up and maybe start a fire. Now you'll notice back here, we had one switch leading in from the street to all the circuit breakers. This guy here is, you could just call it the kill switch. It's not actually a circuit breaker, but it is a switch that is in your breaker box that is above all of the circuit breakers, that it just says main. And if for some reason you needed to shut your house down, period, because you weren't sure what was going on and you just needed to kill the whole house, this is where you would go to in your breaker box, and you would just turn that switch off and it would cut the flow to everything. Now you'll notice we still have power, so to speak, with voltage coming into the house, but we do not have a complete circuit that allows any electricity to flow anywhere. And so as a result of that, it keeps us safe. Now, most people, except in extreme emergencies, would ever have to kind of go to the kill switch. Now, you'll notice at the moment, they didn't come back on. And there is a reason for that. Remember how I told you previously that this power supply only provides 1.5 amps? When we turned this on, we kind of exceeded that, and it actually shut itself down. So what I'm going to do is I'm going to shut one of these off, and you'll notice that the other 2 came back on, because our current for these 2 guys is less than the 1.5 amps. Now, I'm going to see if I turn this on, if it exceeds it again. Now, because we didn't do it all at once, we were able to slowly build up and exceed the 1.5 volts. But if we try and do this as an entire thing, we don't get that. Because when the lights first come on, it demands a much larger amount of current, and it exceeds the maximum that our power supply can provide. And this, even though you can't see it, has a safety switch built into it, just like I'm describing here with these circuit breakers. that when the current is exceeded, this automatically shuts down and doesn't let current flow any further. So let me turn this back on and see if we get it back. Yep. All right. And so if we needed to go in the reverse order and we started to unplug things, you will notice that the remaining lights sometimes tend to get a little bit brighter because now more energy can get deposited into those. And every time we unscrew something, our current goes down, and that's where your parents would be saying, ooh, we're saving money. So if you could live off of one light instead of two, that's why people discuss, not trying to use more lights than you really need to. Okay, so this is how your house works. It's pretty amazing. And I think each of you down the road, when you become a homeowner, this aspect of your house is something that you should be familiar with, so that in case there's an emergency or in case something happens, you know where you can go to reset circuit breakers and where to access things to keep your family and your home safe. I hope this has been interesting, and I think I'm going to follow up with an assignment for you guys where you have to go locate your breaker box and send me a picture of it so you can show it to me. So again, I hope this has been informational, and we'll see you next time. Bye.